Hi and welcome to the git-python development stream. Yet another day. This is Byron and I'm going to have a look at this new ticket right now. It's just kind of a starter because that's not a real ticket, I think. No module named utils compat. Howdy, I have the latest gitdb. So you have the latest gitdb from here. Let's have a look. Installed and then the latest git-python. But I get this no module named utils git, so that is coming from git-python and it wants gitdb utils and then compat or something. Yes, there we go. So apparently the gitdb that is in the path doesn't have utils at all, which is new. Which is quite new. So I guess that in fact it's not the gitdb version that he thinks he has that is actually in the Python path. So I could assign myself. Let's put this into this milestone just so that we can close it in time. Yeah, I'll just request feedback here. Well, let's post this link. One more thing, I just want to see how it works because git init, I think there was a part that initialized externals, but we don't do that anymore. So as you can see, we just rely on the existing Python path here being set up properly. And if that is not the case, then basically, things will not work. Because there's no custom code. There was old code that basically set the Python or the system path itself up so that it will prefer local installations of gitdb, but that's just not the case anymore. So I guess the ideal development environment doesn't have gitdb installed on the Python path or in the side packages for that matter. Yeah, I guess that's all I can say about that. And I will of course close this ticket when it's about to release 036 in any case. Good. So that one is done. That one I've answered as well. Don't I? Yeah. Let's request feedback just for me as a marker to tell that I'm kind of, in a waiting state there. So the one that I actually want to do now is this one because there's new data And I'm, quite excited because I kind of had the idea that the current implementation is too complex anyway. And, it obviously leads to issues here, which is a bit astounding. But on the other hand, that's how it is sometimes. Let's keep it as simple as humanly possible. And the current implementation is just not that. And obviously it leads to errors. All right. So actually I will remove that feedback tag. The issue here is that there are two sources of data that have to match up perfectly. One is read from the std_err channel of an existing git fetch or pull or even push operation, and the other one is something that is written into the fetch head. And these just must match. In this case, it doesn't. We have a large amount of branches that are being fetched here, like above 800. And all of a sudden, things go out of sync. So the data I've now received, that I really will try not to show here because it's kind of private, indicates that up to 14 branches are missing from std_err. And what we figured out so far is that the code that runs here uses poll to basically fetch or deplete the entire std_err channel. That is the idea, at least. It should deplete the entire one, but apparently it can't do that. So even though I have the data, this only shows me that the last 14 lines are missing from std_err. And I won't be able to reproduce this unless I do the same thing with the repository that I don't have access to. Maybe there is a repository that has a lot of branches that would allow me to do that. Yet I don't currently think so, So what I will do is kind of poke in the dark a bit and work on a separate branch for this, just to see if I can simplify the way this works to the point where it truly works. And then if he tested and verified this, I will merge this in. So let's do this. Change to issue 232 reproduction. There we go. Did that work? Yes, I am there now. And I think in git command there is this handle process output that can use poll or will use poll if possible. And this code, it gets events, and whenever some stream 1 of 2 here is ready to be read, then it will read a line, just one line. And I think that could be part of the problem, that the past does read just one line, by the way. No, dispatch. Yeah, it reads just one line here, and that's the point. And maybe there's more data available, and I think this is maybe where things go out of sync here. And at the end, it gets gets an event for result closed, and then we will just read all or deplete the buffer. We read everything that there still might be. And with this one line at a time reading, we might actually not get it all. What the information that I would be interested in is how much bytes there are ready to be read right now in the moment of the event. But I can't ask for that. So I guess this code itself has potential for not working as expected. And as I know, even if that code runs, which always runs on my installation here when running Python 2, even that has issues because lines can get scrambled. So after all, I want neither of this to happen. Either I fix this up somehow. Probably I should read up on how to use poll correctly here, because it is event driven, and that kind of is implicitly dangerous if you don't really know how this thing works. So, that's kind of my problem, I guess. So I really would like to not use it at all. And I realized that this might even be possible if we have a look. Oh, that's actually not here. It's in remote fetch. Oh, fetch. Let's try that again. So what we have here is a process that has std_out and std_err open, But the only thing we're really interested in is std_err for progress. See, get fetch info from std_err. So I guess, on this guy, he opens up std_out automatically. So either we tell it not to open std_out in the first place, or we close it afterwards. And closing it afterwards might be the way to go here, because then I can just, without doing anything special, loop over everything here, or loop over the std_err channel and do my thing. And that's really what I want. That's some debug code that I will remove once we are known to be working here. So let's do this. This handle process output is something we don't do, but we don't do anymore. What we want to do is finalize the process, which might, it's kind of a brute force way to make sure this process goes down. Not the most elegant solution, but it's okay. Just one method call or function call more. That is other debug code here. That's fine, we'll remove that later. And now the only thing we have to have left doing is to actually traverse the lines here. For line in where's the process? Process std_err. I think that returns lines. And I wonder how it returns them. Does it truncate the lines themselves? I don't think so. I mean, does it strip the lines, the white space? I don't think it does. Yeah, it shouldn't. However, we expect it to be stripped, so let's do that. And now the rest, we kind of re-add the line here. Maybe we shouldn't do this. Let me just do it like that to have the original line written back. And now, of course, line is not a string anymore, so we probably want to decode this with the default encoding. So that assumes UTF-8 right now. Yeah. So that should be it, because std_err is definitely a byte stream, and it's up to us to reinterpret this to be a text with some sort of encoding. All right. So here we do that. That should be fine. So that will be removed later. I could probably then concatenate these two lines, but that's for a later point. Okay. That is already it. That will deplete, then the process will finalize, and that's kind of it. So let's run the tests here. Yeah. And pull, let's have a look at pull. There we do the same thing, then push. What do we do during push? Get push info. Question is, does it read, is it interested in std_out? It is. So here it needs that. Here we have to use the current code, even though that is up for improvement. Considering that, I think I should at least consider having a look at it and see how that works. Python select Paul. Tell me about it. I won't trust all the code that I find on the internet though, but let's see how it differs from what I have. Okay, select, we use Paul. Because unfortunately Paul or select only works with file handles up to an ID of 1024 or 1023 for that matter. And Paul doesn't have that limitation. So if you have opened a lot of files, which could happen, then it might be that select just doesn't work for you anymore. So Pol is kind of the only thing I'm using there. Pol is not supported under Windows, so programs using Pol are less portable. Yeah, and select, you know, they claim that, but select on Windows only works for sockets anyway, not for file handles, so we are limited there, no matter what. Let's see. So, show me how Pol works. Pol in, input ready. So how do I do it? Pol in, Pol pri, Pol hub, Pol error. Priority input ready. Pol hub, channel closed, Pol error, error. Channel not open. Maybe I should wait for this too. Oh yeah, look at that. I kind of used that code at some point apparently. So I shall not be blamed if that doesn't work. So then we do the registering here. Where is it? Here it is. Register 2 channels. Then there is a mapping here. Well, it's kind of very similar to what's online here when you search for this. So yeah, I guess I've seen this back then. So let's see if it's Pol in or Pol pri. You know, I don't even do this. I just check if it's closed, then handle that. Otherwise, try to read from it. And closed means hub or error, which is the right way to handle that, I guess. So I don't even I don't even care about that particularly. And I probably should. But on the other hand, you know, that kind of involves all of this. Read only. Yeah, well, that's kind of all flags. I don't know if it's read only per se. Anyway, that won't matter to us. So we do the Pol. Here he does the Pol as well with the timeout. I don't do a timeout here, I don't care. Events, FD and flag, FD and result, okay, that's what we do too. And if this is an event like, okay, we have something here, but it's not the same code even, you know, it's a socket that has a new incoming connection. And that's like a totally different thing. And then you would just Pol on that connection just to keep going, and yeah, it's different. Otherwise he just reads a fixed amount of bytes here. If receive returns any data, it is placed into the ongoing queue. Okay, so maybe that read doesn't block. Yeah. If it's, I mean, it's a socket here, so I think socket possibly doesn't block there anyway. Let's have a look. Socket type, no. Socket IO. Well, we don't have a socket here. I could look that up, but I guess with our file objects, we don't really have it that way anyway. We only have read, Python, pipe read with timeout. I mean, the reason we are using Pol is that we don't want to use timeouts here. Yeah. Just want to have a look at the available functions here, but that probably is the wrong one. So it's just a file object after all. Returns a open, returns a file. Come on. Yes, up here it was. And tell me more about the file object. Please link the file object. I just want to see that here. And now, file objects, there we go. Tell me about it. It's not the first time I'm reading this, but hey. Read at most that amount of. Okay. So what about blocking behavior? EOF, okay. Also note that when in non-blocking mode, okay, so we have to use IO control here to put it to non-blocking mode. Maybe we should do that. If we do that, wait a moment until EOF is read, or is encountered. Instead of reading up to EOF, whole lines totally approximately size and bytes, possibly after rounding up to internal buffer size, are read. Objects implementing a file-like interface may choose to ignore size and so maybe that could be something for us, at least in the non-stdr case. Here we just read as long as we can. I mean, if we read from stdr, where is it? Let's see, RedLine slow. Just read 1 byte at a time, which is, as slow as it gets. And then we deplete, or we keep going. But we only read 1 line though, And I think that's kind of part of the issue here too. Yeah, I think that is part of the issue. Also, we are just doing this incorrectly here. Gee. Because if for some reason we can't read a character, which could just mean that, hey, the buffer is currently about to be filled, then we abort and possibly return a half read line. And then we keep going. And I think that's something we shouldn't do here. Yeah, so that's another possible bug. And I'm running into this bug every now and then, and I believe there is a good reason for that. So now for fetch, push is something we have to look at, because push is still running this and I really want to fix this. But for now, we should have simplified it to the point where at least the fetch and pull case shouldn't suffer from that anymore. So let's run the tests. Let's stop talking and start running. Yeah, that's interesting. It wants to read bytecode. Oh, this is why it wants to read bytecode. Sorry. What is it? It's test remote, I suppose. And Python 3.4, well, now shouldn't use poll code anymore anyway, so that seems to still work. 2.7, oops. Seems to work. All right, let's run them all. Well, at least I would expect not to ever see this error again in Python 2, because this code just doesn't run anymore. Yeah. I would expect it to work. Let's check Flake, just for good manners. Flake doesn't like it. Remote 556. 546. Yeah, true. 551. True. How could I? Like so. Oh. Okay, the Git daemon startup kind of failed here in tests. Where is that again? It's in test remote, test base. Is there a test base? Yes, there is. So that should work now. Okay. Sometimes this fails, but it's kind of a... Excuse me, didn't I save this? 5. Come on. Okay, there's a new error. And then we have a continuation error because, yeah, it's supposed to be like that. Green. Awesome. And there's another error. What the hell? What the heck? What's happening now? Is Git daemon not working for me anymore? Tests take way too long, 40 seconds. List index out of range. Assert push and pull. Test remote. Alrighty. So if I run it individually, it still works. Well, still spurious errors, but this time with pull. And pull does indeed... Yeah, I mean, we assume that we have a certain amount of... No, test remote 351, maybe I should make another 351. Assert lang res equals 1, I suppose. Res... do test push result. What do I expect here? Then results. Okay, I just test the first one. So I suppose this must at least be set, right? Yeah. Let's do it like so. Let's do it kind of Pythonically. So that is a list of at least one, or it's an object. Yeah, but let's test if it's a list. Let's do it a bit more explicitly. I prefer that. Good, at least that much we can tell. And now, test these Git daemon errors. No, why can't it start that? Let's try one more time. That's odd. Yeah, I think in any case I can prepare a commit. Remote fetch pull will not use pull or threads anymore, as only stdr is red. This simplification should improve performance and remove issues like those. Those in 232. Let's refer to it at least. All right. Note, debug code is still contained in this commit. Contained here. Okay, did it work? It did. You know, the daemon stuff, daemon cannot be launched and things, that's a different thing. And even though I don't like it, it indeed sometimes cannot be launched because one process is still going down, or the resource is not yet ready in the system because it wants to listen to a particular socket, and if that fails for whichever reasons, then of course the whole thing fails. Okay, so next up is doing the pull. So as I said, I believe, I mean, now I've removed everything here. I removed this particular invocation, so I'm not sure if I push, if the push testing is good enough. Assert, push, and pull. Yeah, we do that. So I suppose if we screw this up, we should at least notice. So let's see. Let's put some randomness in here, and I hope it all fails. Test remote. You should not like pull anymore. And oh yeah, sorry, I just generated an awesome loop that could possibly deplete my memory here. Well, after a long time, let's kill this one. Are you dead? You are. Awesome. So let's do it like that. Jesus, one little fix and I create a bug. Awesome. That's how it is sometimes if you're not totally focused and in the code. All right, I at least realized that something is wrong. That's good. Okay, so let's have a look at this one again. Do we use file handles here at some point? Maybe allowing us to take some code. Paul file example. Just to see how others do it, you know, we don't have to reinvent the wheel and kind of make our own experiences here. Okay, that's kind of where I was before. Interesting. Yeah, so all threads. No, I don't like these. Versus event-based. I certainly. Yeah, it's interesting. It's not trivial to implement that correctly. Yet there doesn't seem to be any library to facilitate that. There must be, huh? There must be a library. Paul library, maybe? Come on. Probably others use that too. Like subprocess. Let's have a look. No, well, maybe not. Multiprocessing probably uses that. And oh, set. Well, what about Sublime Text? Paul. Internal Paul. Process or process Paul. Select Paul. There we go. Close and unregister. Oh. Ooh. Man, no way. I think the version out there, I never unregister. Damn it. Oh my god, this could possibly deplete all kinds of system resources. Okay, this, yeah, I'm looking for, I have to release 0.3.6 as soon as possible because what's online there could definitely cause issues in long-running processes here. All right. And how do we unregister? We just provide the file descriptor. Yeah. Paul unregister fno. Like that. Okay. So std out, std err. That's actually exactly what we are doing. Communicate with Paul. So they do it right. We should be able to do it right as well. Here we Paul. And all right, it even catches interrupt errors that we don't do right now. We should. And then if there's something to be written, select Paul in, Paul pre, okay. If there's something to be read, it reads a chunk. Okay. And it uses OS read for this. Look at that. And that's probably non-blocking. Awesome. So I probably should do the same then, huh? Not use the stream all the time. Yeah. Let's do that. And what else? If it is... Yeah, could it possibly also, I mean, you know, is it possible that even with that code that it doesn't read everything? Because if there's something left here in the buffer, then it wouldn't read it all. And then the next ready event, you know, I don't know when that comes. Maybe the next thing that happens to the buffer is that it closes, and if it closes, what happens? Just unregisters and handles its dictionaries here, but it doesn't deplete it. So I think I'm good with my depletion code, but I might not be good with the current code kind of reading individual bytes from std_err. That might just not be good. Yeah, you know what? I think what I should do is keep these things separate. So first, I mean, in any case, I think it's a good thing here to not use Paul in the case where I just need to read from std_err, because that should just be as simple as it gets. Because this one should automatically finish when it's closed, when std_err is closed or the process is done. And yeah, let's finish this up. I've pushed this. And I guess I also don't, well, let's do the testing. Let's run the Travis test so I don't do anything here. And I will let him know what's going on. So let's get a link to this branch here, which now has new code. Issue reproduction. Remote pull and fetch. Yeah, that's the one. Add domino 14. Good. Let's do this. Put feedback back on. Well, that was unnecessary to take it off in the first place, like 35 minutes ago. But yeah, that is that. And now I think separately I should, because you know, in my original master branch, I don't have the simplification in there, which means that certain functionality runs more often here. And I exactly know how to run which branch, so I can basically test my implementation on master. Something doesn't work here. So much better. Yeah, and this is what I want. So, oh, the unregister code, I think. Yeah, let's finish this up and transfer the code to master. Thank you. So that unregister must go there, that's for sure. Now it's all about fixing. So the std code is possibly bad. Yeah. Let's rewrite this line parsing thing. Maybe we should parse the lines ourselves then, and change this to use file, instead of streams, use file descriptors. Because, you know, just to call stream read here, we don't need that. Actually, OS read, fread is exactly what we want. That's awesome. Read a file descriptor. I think they could be a bit more descriptive. You know, what happens if this and that, and if there's not enough to read, what happens then? Does it return like smaller portions of what it could read or what? And things like that. Gee, you know, sometimes could at least say, if you want to know more, have a look at the C standard library version of read, because that's exactly the same. That would certainly help. But no, nothing. Awesome. And it has been there for like 100 years. Nobody ever improved it. Anyway, probably shouldn't criticize if I'm not even able to use Paul correctly, but hey. So let's also try that. Erno, I think that's a separate module here, huh? Or a package. Erno, yes. So let's do that. Import Erno. And if we Paul, oh no, wait, that's something I've just added. I was just thinking, hey, it's already there. Now I have duplicate unregister calls here, but I don't. So when we poll, it can actually throw Erno. Unless, how do they do it? Erno, if Erno is not an interrupt, because these, here we are, because these interrupts, e-interrupt, well, wait a second. I think e-try again or something. That's something, for instance, that happens all the time on free or on BSD systems like OS X. E-inter is e-interrupt, right? E-inter. Or am I totally wrong about this here? Oh no, what the hell? Eintracht? No. Oh man. So let's do it like that. Means what? Or maybe I should just use the Erno here. E-inter, interrupted function call. All right. But it's not try again. E again, exactly. Resource temporarily unavailable. Maybe the same as would block. Yeah, interesting. Yeah, so that they don't check for. I think I should just trust year-old code here and do it exactly as they do. If it's interrupt, do that. Otherwise, raise. With do that, I of course mean continue. Okay, now I will change this code to not use the stream anymore. Do I need the stream for anything? Deplete buffer, stream dispatch. I just need the stream for RedLine, and otherwise I don't need it. All right, so I will not have it. Yeah. That goes away. Goes away. Then have a look at what fdmap does. Yeah, that doesn't work anymore either. Dispatch line, I think it's that plus fd. So because this is now, let's call it file number or something. File number. And the single read line, I don't like it. This has to change as well. Because we could have more lines to read, and we should probably kind of read as much as possible. And this is something we should do, but we should do so in a non-blocking way. Do we have an OS read? No, see? Something we have to implement ourselves then. And handle buffers and such and blah. Then we need kind of our own memory here. We need some storage for that per stream that we are trying to read. And it doesn't make it easier. But let's try to get it to work in a simple fashion. First simplification, use fno directly. Fno, so here we have os read fno 1, like that. Highly inefficient. I'm not proud of that. Look at that, now we can't use RedLine anymore, haha. But on the other hand, we don't really want that, as it just, we have to fix this up anyway to read as many lines as it wants. And I guess we want to improve this one here to kind of read all the lines there are and return a buffer of possibly, or maybe keep unused bytes separate here. Yeah, I guess something along these lines. And this guy should really be more like an iterator and yield as much as possible. I need like multiple lines. And then we just dispatch multiple lines here to the handler at once if possible. All right. Yeah, I shouldn't be that distracted. Sometimes my phone blinks or lights up the display, and then I have to look at it, of course, and that distracts incredibly. Maybe I should turn it around, but then it will blink. Maybe I should put it away into a case that is black and dark so I don't see anything. Yes, done. Good. back to FDmap. So that seems to be all right. Then we do this, which shouldn't be the case anymore. fno, and then the value. So now we do items. Unpack it. And then we go that should be fine. Then we do fno again. Probably we should do items, considering that we need everything here. Yeah, handler, readline. That should be renamed to read lines at some point. Okay, that's not the case anymore. We don't need that. Handler, readline. That's just fno now. Awesome. And that code is kind of used only for push now, because push has an std that we are interested in. And all we have to do is read that in a non-blocking fashion. Terrific. Yeah, as I said, I don't totally trust this code, and they're lucky because they don't have to read lines here, which complicates things. But hey, let's do it. Read lines, read line fast, read line slow. So we now do it all manually. And we should have a function that reads lines from a preset buffer and returns the unused lines, basically. And then we can, or the unused portion of the buffer that doesn't have a separate line. And at the end of the file, you'll just kind of use that buffer. Yeah, something like that, maybe. I mean, deplete buffer should take care of that. So, I suppose we have a read line slow. We have, yeah. I mean, this guide also handles carriage returns, which happen in case of progress messages, and it handles new lines, which happens in all other cases. And on, as we are talking to Git, it's kind of never like a double value there, like /r/n, like on Windows, I think, or /n/r. So I think we should be fine with that kind of code. Read lines slow should be it. And then basically we have the same kind of reading, for all of them. Read lines. That will now just be an iterator. Question is, how do we handle the buffer, the reminder of the buffer? And maybe it should return the number or the last byte that it read. Yeah, something, or the ID, the index of the byte that it read last, or the index of the last character that it processed, basically, so that the rest of the buffer is obviously. Yeah, let's do it like that. Let's implement some sort of end of line index that we return as well. Okay. So we have to pass in a buffer and return multiple lines. Start at this one. We read binary buffers, and this kind of thing is not necessary anymore, obviously. So buffer index shall start at 0, and that's the length of our buffer, while buffer index smaller than, maybe we do, oh well, I don't want to use range, I can as well do this then. I don't like the for in Python, it's kind of oversimplified, and you know, simple things like that all of a sudden get awkward, at least to me. How would I do this? For, yeah, I have to do an X range then, and then, you know, X range is kind of prone to Python 2 and 3 incompatibility, so you want to use this from compat, and all this kind of gets too complicated to me. So just say, let's get the character here. From buff. And I actually want to have a character. So that's also dangerous, because in Python 3 this will be an integer, whereas in Python 2 this will be a single byte string. So what do we do? I think I have a compatibility helper that does that. Get that. Oh man. Byte ord. Yes, that's the one I want. Man. Honestly, Python 2 and 3, I don't like it. I mean, sure, it's inconsistent. They changed something. They had the reason to increment the API version to 3. But do I like it? I mean, is Python 3 better than Python 2? I think so, even though it's slower. But do I want to maintain Python 2 and 3 compatibility? I don't think so. It sucks, even though it's relatively simple, if you know what's going on. But it's kind of, I'm not a fan. I'm just not a fan of Python. I must admit that. I don't like Python. I like pretty much everything else more. I love Ruby just by looking at the code. I've never written much of Ruby though. And that tells something, you know? I would wish that Python is in fact Ruby. Then I would probably be much happier. Probably. I've never written it, so who knows? So that is not the question anymore. The char will always be there if it is a line. I mean, we should return with line endings or without. Let's return without line endings as before. So we yield the line, and we shall also yield the index of the last character here. Or the character that we have used, maybe +1, so that the guy who uses this can just, you know, doesn't have to do anything, it just truncates it like buff, then this, and this will naturally work. If it's not +1, then he will duplicate the last character, which he would be me, and I don't want to deal with that. So let's do it like this. Yield the line. While there is something to read, yield the line. Otherwise, we just stop the iteration, because the last line that we parsed will be that guy here. Okay, that seems easy enough for a buffered line parser. Now we just have to deal with the buffer and read lines, I guess. So, read lines. This one will do what? Yeah, do we need an iterator here? Yeah, I think it's okay to use one. Okay, so we do read buff, which is, well, let's do it like they do, huh? Must be, maybe it's a good number, 1 page. Page size, maybe we could ask for page size. Memory page size. Python memory page size. Memory management. mmap, size of memory page. Size of memory page. Maybe mmap is the one that does it. page size or something. Yep, that's the one. Do we have mmap everywhere? I think so. Let's try. I mean, page size, that looks good enough. Let's use that one, huh? I don't particularly fancy to import mmap just for a constant, but what can I do? We don't use it besides that. So let's do this. Buff is os read fno mmap page size. Thank you. And then basically all we have to do is to, oh yeah, we have to manage our buffer, obviously. So the buffer, the reminder of the buffer should be a slot in here somehow. Maybe an empty list. And then I have to deal with that. Yeah. Read lines fno. No, the buffer so far could just be an empty byte string by default. Like so. And yeah, you know what? Just store it here. And I let the guys take care of that themselves. So last buffer. What we do is we just append them to make sure we handle all of this kind of in an appropriate fashion. That's also slow here, but you know, who cares? And then we just return. Oh no, wait, we don't return. We just want to return individual lines here. For buffer index line in read lines buffer fno buff yield line. And then last but not least, we should somehow return manage. Yeah, we need this. We need some sort of variable that we last buff list that we can write here. I have to get this stuff out. Last buff list. Like so. And now keep reminder. Could be empty though, that's fine, we don't even care. Last buff list 0 equals and then we have the buff plus the reminder of whatever there is. And we need a list here once again. Kind of make this work. Change signatures all over the place. This program is not working anymore. So let's be very careful and work from the top to the bottom. One at a time, one line at a time. Last buff list, that should be good, that should be good. I'm confident about that one to be kind of doing the right thing for each line to parse from the buffer. The good thing is that now the line parsing will be faster. And it's, you know, I think it's probably less fragile now that I read bigger chunks here and use OS read. That's awesome. The question is, does that throw then if we read on the closed buffer? It should. Yeah, it should. But hey, let's wait for it. Let's wait for it to be happening. We might catch this here. Yeah, let's see. We wait for it to be happening. Lots of code to rerun here. Okay, and now the read line handler is something we don't care about anymore because it's the same for all of them. Good. Now work through this one. Dispatch line, it's now doing many lines. For line in, we just use read lines. Fno, and then, yeah, let's have a look at this call. Well, let's have a look at this one because it changed so much. Standard out handler, blah, 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 blah. So what do we have here? So that works, RedLine we don't need anymore. That should also just work. No, oh no, wait. Sorry. Dispatch line, that will still work. Here we have a buffer, buff list. Who cares? Just pass it on. Like so. Unregister. That's the buff list now. Buff list. Okay, so that should work. Now let's have a look at that guy. Takes a buff list. Dispatch line passes a buff list. I don't know if we probably need this one just for the threading thing, but let's see about that. We might just be able to call dispatch lines. No. Let's call it like this. Okay, so here we get a buff list. And we call this, last buff list is fine. That's a buffer, good. Good, what do we get here? Oh, we decode this guy. Look at that, really? Oh no, wait, we decode each line, that's fine because we get byte lines here. In RedLine's fno buff list, that shall do it. We don't decode that right here. And then we return the line, really? Did I mess up the logic here? Why do we return the line? Okay, just for him to kind of see that we are done. Let's check this. I don't think that we need deplete buffer anymore. Maybe we do, because what's in buff list, what's remaining there is obviously a last line that we have to dispatch as well. But I don't think this guy has to necessarily return the line anymore. No. Dispatch helper, what? Like, yeah, I mean, we will only get a line. Well, we could have an empty line because, do we strip it? Yeah, we do strip it. So possibly there is an empty line in there. And we definitely don't want to pass empty lines on. Could confuse parsers down there for each line. All right. Let's get this right. This is all irrelevant now, I hope. All right. So then we pass on the line. Oh yeah, we should decode it because this guy requires a string. Good. Then handle it. If there's something happening, we just keep going because we want to deplete the buffer. No, so if the handler constantly fails, who cares? We have to make sure that we don't block because buffers or pipes run full here. Dispatch lines looks good, and deplete buffer shall actually just run. Well, should it run dispatch line one more time? I don't think so. Well, maybe it should. Maybe it should, yeah. Should run it one more time. Or yeah, well, it could be possible that the buffer has like 8 kilobytes in there. All of a sudden, you know, I don't know. I don't trust this code. It might just work. But in theory, I can imagine that, you know, buffers run full real quick. We don't get that many events, and all of a sudden we end up with a buffer that, or with a pipe that has like 8 kilobytes in it, but we just read one chunk of 4 kilobytes here, and then we end up not reading at all. So this deplete buffer, I really want this to work. So how do we do this? Maybe this raises or something. Yeah, I don't know. It doesn't say. I think it should raise if you try to do it on a closed one. But also I don't want it to block, and yeah. Let's see. Maybe this should also, maybe it should raise if there is nothing. Because there should be something here. All right. Yeah, I don't know. Deplete buffers. Oh yeah, deplete buffers is also supposed to do a full dispatch here. Which means that this has to run as long as possible. And it must be blocking too, if we're in threaded mode here. All right. So I guess we should return something to let this guy know that we are done. Or it raises. It could throw if we are done, but I don't know if it throws. Well, it has to do something. We have to get out of this while loop. And if we do, let's just move on for a moment. We should check the buff list, and if there is something, we should basically handle it. Handle F. I mean, this guy wants to read it. Maybe we just read lines from buffer and then call the handler ourselves, which is kind of all this code duplicated. And that's something I don't like. Read lines. Yeah, if that one wouldn't want to read from a buffer but just gets one, we could, yeah, actually dispatch lines is what we want to call. It should just do the right thing. I want to be able to dispatch lines with a buffer, with the reminder of a buffer. Or I just implement this myself here. I mean, after all, it's just the last line anyway. So let's do it. Even though it's kind of this portion of the code that I want here. So here we need a line and a handler. And that's it. Yeah. And it will take care of the rest. And we will just return the line for the fun of it. Like so. With line and handler, return line. Yeah, I kind of split up the code here just to make it work for us. This guy dispatch or just reads the lines here and passes them on. Awesome. Maybe we can simplify it even more now that this is down to a simple loop over something. Maybe read lines should just do the handling then. I mean, come on. Read line could also dispatch it. Read lines and dispatch. But it won't read it from a buffer then. I mean, that's still something we need, right? We need it to dispatch it from the single byte buffer. So that's a line. Yeah, I guess that's what we do for now. Dispatch single line, then line and handler. And checks handler every time. Do we need this? Yeah, I mean, it's probably convenient, comfortable to call if he checks if the line is there. Sorry, if the handler is even available. All right, let's do it like that. So now, if buff list, if there is something in there, let's put it on. dispatch single line. We put the buff list reminder and the handler, which can or cannot be set. And that's the rest of it. Okay, so now all I want is to be able to tell if the file is closed or if there's anything happening. So either this throws and we handle it, but yeah, in any way, dispatch lines should return something here. Otherwise we get caught up in a loop. Or there should be an exception. Yeah. Could count the lines. Yeah, I'm a bit afraid to I should run it somehow to learn about the code and what it does. I just don't want to get caught up in a loop right away. So make a decision, Sebastian. Just decide. Okay. Let's just say if there is no line anymore, then, you know, LC line in enumerate, if I could write it like so. If there was no line that we processed, we can probably abort. Oh, by the way, the whole return value is wrong. Gee. Return by and an empty byte string. Oh wait, we yield that stuff. Sorry, that is correct now, because the last line we read is, you know, the last value that this one will get, and that's the pointer to the first byte that we didn't process. That shall be fine. This read lines takes care of that. Yeah. Keeps this pointer here, or this index, and we'll then use it to cut off the remaining bytes and keep them for later. So that while loop should possibly work now. If nothing is coming out of dispatch lines anymore, then obviously maybe we turn that around. Then obviously this one returned nothing anymore. So we couldn't even yield a single line, or through. Let's see what it does. Does it raise or not? We will find out. Let's see if that works at all. Probably not. Lots of changes. Test remote. Python 2.7, that does not use poll, it uses threads. Fair enough. Ha! Git command 34. What? All right. Unexpected indent 65. Yes. Told me even. Int object is not iterable. I have dmap keys. It should be items. Oh. That looks like a loop. Yay, we are in there. Because all this kind of doesn't work. Yeah, it's a bit sad that I can't terminate that unless I kind of send it sick interrupt. I mean, that's sick int, and I don't know how I can send sick term. Sick term bash send sick term. Sending signal to processes. Yeah, I know how to do that, but I want to do it with a shortcut. This is why I asked for bash sick term. And before I use too much memory here, let's kill this manually. IPython, here we go, test remote. Yeah, because Control C sends sick int, and that's not the same, obviously, as sick term. So tell me, how do I send this? Because that's something that could happen to us more often now. Don't need that. Traps shell forward sick term to child in bash. I want a hotkey. Bash sick term keyboard shortcut. Terminal sick term with a keyboard shortcut. Exactly. STTY is responsible controlling this. You may already have one set up. You can check by doing STTE. Ah, yeah. And here we have Control C, sick int. STTY-E. I didn't know that. I know. I don't know a lot about that, that's for sure. Look at that, you know? Took me like years to kind of realize, hey, Control C is good, but there must be more. What do we have? We have sick stop. Oh yeah, I've probably called this a few times. Stop, start, sick interrupt, Control C, sick kill. Good enough. Control U, I never used that. And sick term. Yeah, I mean, sick term doesn't seem to be here. I also don't mind to just kill you brutally by shooting you in the head. So let's do that. Control U. Control U. Die. Doesn't work. Doesn't work. Oh, interesting. Command U obviously turns on and off transparency, but of course I want that on. Yeah, that doesn't work. Awesome. I have to do it again. Old school. That didn't work. Why? Use STTYA to see that. All right. Okay. Discard. Control O. Control S. Reprint. Reprint. Oh, it's kind of weird. It seems to be not totally correct what I see here. Control U. Still. Control U doesn't work though for me. Yeah, do I have to set this up myself? Huh. Probably this is related to my terminal as well, and iterm, maybe I don't want to spend too much time on this. Iterm, and then Control U, delete line, send sick term, running inside SSH. Well, that will probably use kill. That's not the one I'm looking for. Okay. I would rather prefer to send sick term to those than sick int, I suppose. Yeah, okay. I call this off for now. Oops. Good, let's fix it. 90. Okay, it didn't run a single time. Well, fine. True, I should have known that. But today I didn't. Please do not get into a loop. LC reference. Okay, that's the same thing. Oh man. There we go. Yes. I'm sorry. I should have known that. Once again. Okay. Maybe now that we are in a, maybe that doesn't work either now, because read is called too early, returns nothing. And yeah, maybe we should check if the stream is still open or something. Yeah. Maybe we should check Erno. Makes available standard Erno system symbols. The value of each symbol is blah 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 blah. Symbols are not relevant to the underlying system, are not defined. Whoa, whoa, whoa. What's the current error code? Okay, that's a dict. Fine. Yeah, I think that contains just the constants here, because if I call read, usually in C it sets the Erno variable internally, and you can ask for it. But I think here it would raise or throw an exception if something goes wrong. Oh man. That is annoying as hell. Okay. 76. Because I'm doing byte ord, I actually want to do the opposite. I want to do b char. Haha. Silly me. Byte char. My own creation, which was necessary to get to be compatible to Python 3 and Python 2. Terrific. I think on Python 2 it does nothing. On Python 3 it actually does the conversion from integer to a character byte, or byte character, or well, single byte string. No, single byte. Kind of. Can it be a byte string? I don't know. Oh, an integer is required. What? I thought this was a compatibility thing. Python 3 and Python, yeah, well, look at that implementation. That can't work. Thank you. I want to get rid of this loop here, and I want to do so very, very soon. Yeah, the implementation is not correct. Probably it is correct for the specific case where I implemented it for. But here, we need it just to return nothing. Well, let's have our own byte char then. So that shall be fine for Python 3. Otherwise, we just do nothing. Thank you. So now this should work as expected. Okay, at least we don't loop anymore. I think now we get totally incorrect results. I don't know how totally incorrect they are, but they're incorrect enough for our test to fail. That's a good thing, I think. 1 failure, 3 tests ran. So apparently it wasn't all too bad. Let's see how it fares in Python 3, just for my own idea. Syntax error. Wow, 155. I copy pasted Python 2 code as E. That should work. Okay, same thing. Different code branches though. Terrific. Let's do Python 3 first, because it uses poll, which doesn't use threads, but which is possibly easier to understand. Deplete buffer runs similarly. Okay. Delicious water. It's kind of a different thing if you're talking all the time. It's really training for your voice that I'm not used to. It's totally underdeveloped. But hey, that's how it is. Practice is required sometimes to get better at something. Who knew? Good. Let's see what's in there. Maybe there's a line missing or something. Oh, that's the assertion that fails. Fetch info lines is 2. Let me guess. Fetch head info is 3. Awesome. So we are missing exactly 1, which could point to us being unable to deplete buffers here. And deplete buffers should get in here. But apparently it is not. Dispatch single line. Do we even need that line? Nobody cares, so we don't return it. Do we get in here? I have the feeling we don't, for some reason. Oh, even though we should. We definitely should. But we don't. We don't get in here. Why is that? Don't I set the value here? Read lines buffer. Sorry, here, read lines. So that's the one. And that apparently doesn't get anything. Why is that? Oh yeah, we always yield. We never get out. Actually, that's why. We always kind of process everything. If we do not, I mean, sure, we actually parse the line to the end, but we don't find a new line here, which means that we just terminate. And the last byte index that was returned is the one of the last line ending, basically. So, yes, that should be correct, yet it is not. How big is this buffer that we read? I mean, with the test cases we have, we probably don't read a lot. Let's just rename this one like so. It's like parse lines from buffer, huh? Okay, read lines. Read lines from file. Like so. Doesn't change a thing. Tell me about it. So we have 2 read attempts, which F no, by the way. Okay, so that's the kind of the depletion part. Maybe we kind of override our existing buffer by not handling them correctly, even though we should not, because we concatenate them. Even if we read nothing here, we would pass something to parse lines, and even if it doesn't find anything, this doesn't really change the way this is handled, except for that at some point there should be a buffer to use here. What is the length of the buffer? Yeah, so we deplete the buffer entirely here. And here we have nothing. How does that work? I'm missing a line here. And 4 is std_err, so that doesn't do anything. Get fetch info. Second time gets nothing here. Even 4, I think 4 is std out possibly. And we didn't close that one here. Just in the other branch, which is fine. I will keep this simplification, obviously, because it should really be so simple then. But here we don't have it. Fine. So that's what we focus on. That's std_err. So we read 157. Yeah, well, that's the 1 line. That's, or that may be 2 lines even. But it seems like we read 3 lines. Let's just be sure. Well, we only run this one test base, same values. I mean, sure, it's the values called in this particular test case. I don't know how many fetches have been created so far. It's in 193 actually. So that's the initial setup. So there it fails already. So that's indeed the first thing that happens. So it should be easy enough to find where the bug is. Still, I think I should have found it already and yet didn't find it. So what does that tell me? I won't answer that. Probably I'm just blind on 2 eyes here. Even though I think I see, I don't. Yeah, that doesn't hit. So, right, if we enumerate this, and if it wouldn't handle everything, well, wait. That's all right. How many lines do we usually read here? One. Oh, interesting. 0 lines read. 0 lines read. Good. And that's where it goes wrong, I suppose. So think harder. If this doesn't contain, I mean, it should concatenate buffers, right? Here, that's our line buffer. We just keep it so far. Oh. Yield line, and we should reset the line. Like so. That didn't happen here. And then we just read this character, see if it's done. Otherwise, you know, end line. Okay, that's fine. So that should do something. I think that kind of failed, possibly miserably. Yeah. That is definitely a bug. Let's see how it works now. Oops. Ah. I thought it was crashing, but it didn't. Probably just printed a whole lot of information here. Well, not too much. All right. Let's try in Python 2.7. That uses threads that mess up. As usual. And I just removed my debug code here, but there it is again. And what do I see? 1, 0, 0. Okay, that's std out, that's stdr. Yeah, it just gets one line of something that's probably are 2 lines, and here it gets 0 lines. Why is that? We call deplete buffer right away, but it doesn't work as expected. Dispatch single line. Dispatch single line. Yeah, I think that that goes all wrong here, the deplete buffer. Well, considering that this one here returns 0 right away. I mean, this one should have been... Yeah, let's have a look at the size of our buffer. Our last buffer. Well, should always be 0 because that's a byte index. So apparently we have managed to read all. Does it mean we have a long line here? And what does it mean here? If you read it all, why is there no line? Oh, now I get it. My counting is still totally wrong. Oh man, I'm so stupid. Because I go through, increment this. Last line or line byte index is 0. And we keep it for later. No, wait, actually it's not. No, it's not true. My counting is not wrong. Shouldn't be. Because I don't yield the byte index at the end. I just yield it when there is an actual line that we found. Come on. What are you doing to me? Why is this just one big line? I could just step in there if I don't trust it. But I want to trust it. 84. Let's see. That's fetch info lines, I think. La 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 la. Maybe it's just the new lines that are wrong now. Because that could be 150, that's 167 even. Whoa. Well. Okay, let's step in. Enough. I've had enough. 2. It's kind of the same issue. So it didn't really deplete the buffer, I suppose. That looks okay. That looks okay. Fetch head info. It's 3. Yep. That's all good. Okay, these obviously are not stripped, but that's fine. I mean, just fetch head info. And the one I'm missing is the last one, master. Why would that be? Come on. Yeah, we just run deplete buffer here. There's nothing more to it. While true, while we have parsed the line, then we dispatch the last line. That obviously doesn't work. I mean, we should probably get here at some point. But we don't ever have something in the buffer here. We always deplete it all. How can it be? Maybe we abort too early. Maybe there would be something, but it wasn't fast enough or something. Yeah, that could be it. Because in Paul it works, but we kind of know when we are supposed to be done. And right now we don't really realize when we are done anymore. And that's the problem here. Deplete buffer doesn't behave correctly. Yeah. Should I just keep reading until... Maybe that's something I should do. OS, can I check if something is closed or not? While this thing is open, I want to read from it. Or while it has something to offer, I want to read from it. Oh yeah, while it has something to offer. I mean, the read lines, how is it implemented? Or the iterator on a file. How does it do it? Probably it checks for, hey, while I'm open, I read from you. That's pretty much it. Is it? Where is this implemented? RedLine. Oh. It does not jump there. No. Since when doesn't it do it? Oh, it kind of still has... Now it has it. Still had the old project loaded kind of, and yeah, show me some intermediate state. Lots of read lines. File input, that's the guy, RedLine. So it has a buffer there, sure. We can kind of do the same thing, I suppose. Do we? Next file, what is this? File input. No, that's not the one. No. No. HTTP.io, that's probably the one. RedLine. Okay. Check closed. Peek. Different implementations. Whoa. So their RedLine is much more sophisticated than my RedLine. I would love to use theirs. Maybe I can if I knew that it wasn't blocking. And let's check the iterator here. If not line, yeah, well, if read lines returns nothing, so this means it must block otherwise. Yeah, read reads a buffer of that size. That's interesting. How does it even work? Num read ahead. Okay, local function. There it reads as much as necessary to stay within the limit. Then, yeah, it kind of reads enough for the next line. And then returns it using either peak or it uses individual. So it aggregates the bytes here using byte array, because I'm in Python 3, I think. Probably byte array is also the fastest way to do this. The best. And it converts it to bytes, okay. Fair enough. So they check closed. That's probably the one I'm looking for. How do they do it? If self closed. And that is an internal thing. Flush, close. Well, so it's kind of maintained within the stream. It's not something they ask from the operating system. Yeah, I think I want to read from that thing. I mean, the poll code is kind of different because poll knows when it's done. Even then I'm trying to read from it, you know? It tells me it's closed, but I try to deplete buffers here. And it didn't raise. So yeah, let's try that. I want to know. Let's use OS open. What do I want? Like some git ignore file, exactly. Let's use that. Read binary. F open maybe. Oh no, actually it wants this read binary is just OS no. It's one of these open binary or something. Oh, blah. It's not O. Then it's binary something. Come on. Where is it? It's not O. It's maybe binary is implied, but I know that there is a flag for this somewhere. Yeah, well, it's not in the O flags. We could also write binaries or write in binary mode, so I guess that is why. It's not an O. P seek write if continued blah blah. Well, then just like so. Okay, there's my open file. Let's read a few things. Okay, thanks. Now it's empty and tells me nothing. So, but a read on I mean, what happens if I read a pipe, right? Pipes, I mean, this doesn't throw here. Oh man, this takes too much time. It should be easy. I don't want to be that low level just because I want to be able to parse lines myself. Man. So, what do you have for me? Reading something with flags maybe. F, I mean these F prefixed ones. fd open, fstat, fsync, truncate, pathconf. What's this? Configuration limit name. Okay. Unrecognized configuration name. Yeah, well, fair enough. Yeah, that doesn't help. If they do is-close checks with their own private variable in Python, then I suppose there is no better way. I mean, read must return, you know, if you do an f read in, there must be some error value, you know? You must know why you received 0 bytes. Was there nothing to read? Was it closed? Was there an error reading? You know, this must be something I can ask for, even in Python. So, where? Damn it. You know, this would be C, it would be easier actually, much easier. Because information wouldn't be hidden from me, or at least I would know how to get it. Man, maybe I'm just stupid, could also be. You know, I don't like Python, I must say that. Or I don't like myself because I can't use it. Yeah. Okay. That's Python 2 apparently. Even though I'm on Python 2.6 branch here. Yeah. It checks for closed, it reads the next thing, it assumes that if there's nothing, it's empty. What happens? Yeah, well, I don't know. Probably there's an easy solution to this and I'm just not getting it. Let's just assert here and see if we can get more information about the state of the program. Three, 4 actually works. Okay, what about process std read? There we go. So that is still not empty. And at some point we did a read from this pointer here.